Okay. Just double checking the volume is working, or the audio part is working. And this one is going to be louder because I put the microphone right next to me here, because I think today I'll be using the screen a lot more than the whiteboard. Okay. So the first thing we'll do, or first thing I'll do, is going to give you the solution of the homework assignment. So we'll go to apps.lostreels.edu. Well, maybe not use this account. I'll just use my usual account. Go to App Inventor and create apps. And we'll go ahead and create a new app for this. Or we can just use the one that I already had. Okay, so let's go back to my project. And I already have the bouncing ball project done, in my name. So we'll start with this one. And then the other thing I would do is I would take a look at my own homework assignment, because I cannot do a homework assignment without knowing what I am expected to do. So we go to the homework assignment. Is that the right class? Yep. So we go to cisp362. Go to the homework assignment part, which is under drawing in 2D. This is our homework. All right. The first thing it describes is to use a global variable to track a number and name the global variable HP. Okay, that's pretty easy to do. I'm going to bring my App Inventor screen closer to my assignment, so this way I don't have to go back and forth I don't have to go across the entire screen to go back and forth. So we go back to the homework. HP is the global variable name. So we go to blogs, and then we just create a global variable. Go to variables, and then we just say initialize global name, in this case HP for hit point, to 10. So we go to math, pull the constant, change the constant to 10, and that's it. Okay, we are going to reinitialize this 10 when the start button is clicked, but we should give it a number to start with anyway. Alright, so getting back to the assignment description. Create a button to start the game. Until this button is clicked, the ball should not move or react to any touch events. Okay, so there are several things you can do about this one, and one of those things is to take a look at the ball property. So go to the ball and look at its properties. It has got several things that might be useful. One is the interval, one is speed, and the other one is whether it's enabled or not. Okay, so now the question is, well, which one is going to be useful? Well, instead of guessing and trying to experiment and find out okay, which one works or not, we go to drawing and animation, and we go to the ball sprite and just click on the help here and then click on more information. So this way you are reading the documentation on the ball sprite construct in App Inventor. So there's no need to really guess anything. So it says right here, enable means to control whether the sprite moves when its speed is non-zero. Okay, so if I disable the ball, it's not going to move. Okay, and then the other thing I also want to do is to make sure that before the game starts, it doesn't react to anything. Okay, so I'll keep that in mind. Heading doesn't seem to be useful. Interval is the in milliseconds at which the sprite's position is updated. But since disable should fix what we are dealing with here, we'll just use disable. So it should not bounce, should not do anything. All right, so getting back to the application itself, and unfortunately this one is also zoomed all the way out, so I'm going to zoom all the way in. So I'll zoom out again just so that it's easier to take a look at the application. So we switch back to blocks here, and we already have some code here. Ball 1 is already responding to edge reached. It's also responding to touched. Okay, I didn't say that you cannot have additional variables. So if you want to use additional variables, you can. Okay, you don't really have to. But the first thing we need to do is when we initialize the game, when we start off the game, we have to do certain things. And remember this procedure here? We talked about this, I think 2 classes ago. This is a subroutine. The job of a subroutine is to contain a chunk of code where it will be utilized from multiple places. That's the first purpose of a subroutine. The second purpose of a subroutine is to simplify your program, okay? To make it look simpler, because you're containing the tedious logic into its own block. Then from elsewhere of the program, you just refer to that block to refer to the complex logic. Okay, so these are both really good reasons to use subroutines. In this case, I'm going to use this to disable the ball sprite. So I am going to go to the ball one here, and then scroll down to set enabled to, and turn it to false. In other words, initializing the game means I don't want the ball to be moving. Okay, I'm not really quite sure whether this will react, whether the ball will react to touch events or not. But from the documentation, it doesn't say anything about touching. So I'm guessing that it will still respond to touches. But I probably want to disable that. Okay, so how do I test whether it is responding to touches or not? We just run it, right? We run it, but we need the touch to give me a visual clue that the ball is reacting to the touch. Okay? So we can do it using a notifier, or we can just use a label to do it, or we can just go ahead and change the ball color to indicate that. Okay. So what I'll do is I'm just going to test it, just out of curiosity. Okay, just out of curiosity, I want to find out what is it going to do. And so we'll say when the ball is touched, okay, we'll go ahead and expand the block, and we'll just go ahead and change its color. And I got it done already. Okay, so in this case, okay, let me. This is not. This is the problem when you expand a block. It is too big to be displayed. So I'm gonna reorganize everything a little bit later. There we go. So in this case, I set the background color to pink and set a timer. So basically, when it is touched, it's going to respond, and the screen color is going to change. So that's good. That's good because we now have a visual clue that the ball is being touched. So the next thing we're going to do is to start up the emulator, because I want to see whether it is going to react to it or not. So we go to Google App Inventor, commands for App Inventor, AI Starter. Now we can go back to the browser, and then we can go ahead and test the application. So we go to connect to emulator and give it a test. But this is really just out of personal curiosity, whether it is responding or not to a touch event when it is disabled. Did anyone use the enabled feature to turn off the ball so it doesn't move initially? Or did you guys just turn the speed all the way down to 0? You used to disable? Yeah. Did you test whether it reacts to touching?
I did.
Oh, okay. Did it? Oh, so disable would also turn off the touch event. Okay. But it doesn't hurt to try it, just to confirm, not that I don't trust you, but I want to show the rest of the class how this is how you test it when it is not documented. I'll just turn off some of the tabs that we don't need. I'll keep this one around because I need to know that. I need to remind myself. Okay. Because when we read this documentation, enabled is really just saying whether it controls whether the sprite moves when its speed is non-zero. It doesn't say anything about touch events, so it's not documented. All right, so the app is almost there, and I don't want to click the start button, and I just click on the ball. It's not responding, because if it were responding, it would have given us the color change in the background, but it's not. Okay, excellent. All right, so let's go back to this code here. I just have to be very careful about what the subroutine is when it is called to initialize the game, are we talking about to disable the game before we start, or is this right before we start the game? So from the context of this call, so we have to find out where this procedure is called. So we have to expand all the blocks. Let me see if I can expand all the blocks at the same time. Expand blocks, everything is now expanded, and then rearrange everything vertically like that, okay? And when button 1 is called, it is initialize game. So that would not be the right thing to do, because this is actually, I'm not starting the game yet. So I'll take away this block here. And let's see what else. When did we call initialize? So when the screen is initialized, I call initialize game. That is okay. When canvas 1 is touched, initialize game. That was only for testing, so we can throw that away too. And let's see, what else where else are we calling it? Nope, that's it. Okay, so I think we are good now. All right. So it's a good thing to know that when the ball is disabled, it doesn't respond to anything. With the click, it doesn't respond to click at all. Okay, good. Okay, so let's go back to the description here. Create a button to start the game. Until this button is clicked, the ball should not move or react to any touch events. Well, we already have the button. If I go back to the designer, the button is already here. So the question is, what am I going to do when the button is clicked? So we take a look at the button click event handler, and I think right here, we have to start the entire game. I already called the initialize. It doesn't hurt to call initialize again, but then I have to enable the sprite after that. So we'll go ahead and call initialize. Go to procedures, and then we say call initialize game, and then we have to enable the ball. So we go to ball 1 and enable it. We go to set enabled, and this time we use true to enable the ball sprite so it will start moving. And if I switch back to the emulator, I click start, and now it's moving. If I click it, it does change the background for half a second, and then the whole thing stopped. But that's okay, because I just verified that the start button does work. Now the next question is, why did it stop when I click it? So we have to let me see how I can better rearrange everything. Sort blocks by category. Okay, let's see if that works better. I have a okay, let's try that again. I click start, it moves, it bounces off the walls. When I click it, it stopped automatically, and then the background color changed for half a second, and then the whole thing stopped. So now the question is, why is it stopping? What do you think? What can make the ball stop? There are only a few things that can make it stop. And it all happens when what did I do to make the ball stop? I clicked on the ball. Okay, very good. So we start with that. Okay, and this is the whole thing. Okay, I set the clock, I changed the background color, and I call the bounce procedure. Okay, and what do you think is the reason why the ball stopped? Well, let's take a look at the bounce procedure. Okay, this is the bounce procedure call. This one is provided by App Inventor, so I don't think it's the problem. Closest wall, on the other hand, is my subroutine. Remember, and this is what we talked about. This is what we talked about in the previous class, because I wanted to give you guys a head start on how to implement, how to find out the closest wall. and we look at the numbers. What does it give us, as a result? It gives us a 2 or a 6. Is 6 a valid number for a wall? Do you guys remember, how we drew out the numbers? It goes from 1 to 4, and then -1 to -4, or is it 3? 0 to 3, and negative. No. It has to be signed.
1 to 4 both ways.
Okay, 1 to 4, and then -1 to -4. 6 is not one of those numbers. So when you try to bounce and you give it a wall number that is not in the range, that's what it does. It just stops. Okay? Well, but that's okay because I intentionally gave you the wrong code in case you forgot about that. Okay? All right, so that means that this is what we need to fix. How do we calculate the closest wall to the ball itself, given the ball and given the canvas? We know the logic, the structure of the logic is about right. Okay, it's not entirely right, but it's close. So now the question is, how do we fix this so that we can get the 8 directions or the 8 possible wall numbers to bounce? Well, those are called edges, but one of those edges. How do we make it happen? Any ideas? Okay, we know this block. We'll just kind of throw it away, okay, and start from scratch. So given the ball and given the canvas, how do we figure out which edge is the appropriate one? Which edge is the closest to the ball? Okay, let's take a look at the control structure here and see what we can possibly do in this case. And we'll start from the beginning. This looks like you can do it, but it doesn't, because in this block here, there's a little notch here. So that means whatever block we select has to fit this notch. Okay, so this is not going to do it. This is not going to do it. So we keep going until we see, oh, if then else can do it. And get start value has nothing to do with this program. So the only thing we can do is, unfortunately, if then else. But it's not too bad, because you can have additional if then else within this too. Okay. So what we'll do is we say that there are, do you guys want to go for the 8 possible direction, or do you want to do the simplified only 4 direction? Just 4? Okay, nobody wants the 8. It's not really that much more complicated, it's just a little more tedious. So let's go for the 4 first, and then if we have time, we'll go for the 8. Okay? All right, so if there are 4 possible directions, that means you need 4 branches. This will give you 2 branches here. So I will need 2 more of these blocks here. So I will put 1 over here, and then put 1 more over here. So when you look at the overall structure, now we have 4 possibilities. In fact, what I'm going to do is I will put in, okay, I'm going to put in some actual numbers. So I will go to math and put in some actual numbers here, duplicate, put one here, duplicate, put one here, and duplicate, and then put one here. Okay, so I have these 4 possible places to specify actual values. So the if, or the notch next to the if, should be a condition. I should be comparing at least 2 things. Okay, I can specify conjunction or and if I need to, if I want to, but maybe I don't need to do that. All right, so inside this block here is going to be a single comparison. So I go to math, I take out a comparison block, and I just put it here. And I know I need comparisons for the other notches as well, so I'm just going to replicate the comparison blocks all over the place. So now we have one single comparison and a conditional statement on the outside, and then each branch of the outer conditional statement is going to be its own conditional statement. In other words, we can draw a picture to represent this. We have one comparison, and then depending on whether the comparison results in true or false, we have another comparison here, another comparison here. And then depending on the true-false of each sub-comparison, then we have another true-false over here, another pair of true-false over here. Is that okay? Does everybody understand the structure of this code? That we have an overall if then else, and each branch of the if then else is also an if then else. Okay? You probably still remember last time we calculated the close to the distance from each edge to the wall. Okay. If you want to simplify the code, that probably is handy to have, because you can actually make use of the local variables in the comparison. So we'll do that. We'll go to variables, and then we'll say initialize local name 2, but this time I'm not selecting this block here. Okay. I am selecting the other block, which is this one here. And then I'll drag this entire thing, put it here, and then put this thing back into here. So the reason why I did that is so that I can calculate the distance to each individual edge first, and then I can make use of those local variables in the comparison. Because otherwise the comparisons will be kind of complicated, and I just don't want to deal with complicated formula when I'm comparing. Do you guys remember last time, we can make additional local variables? So this time I'll do exactly the same thing. We'll have 4 of these local variables, and we'll change those names so that they make more sense. Distance to north, distance to east, distance to south, and distance, whoops. Oh, okay. It's not, another pitfall of graphical programming is sometimes it just doesn't give you enough space. Okay, let me see if I can do this. There you go. So distance to west. There we go. So now we have 4 variables, and I have to initialize these 4. Can anyone tell me how do we compute the distance to the north edge? Okay, so you guys, it's the y coordinate of the ball. Okay. So what we need to do is to say, okay, we need to get the y coordinate of the ball, but this ball here as a parameter, it doesn't really say that it is a ball, okay? We have to, quote unquote, cast it. We have to say, look at this parameter as if it is a ball sprite, then go ahead and get the y coordinate of this particular ball. Do you guys remember how to do it? I almost forgot to do it, how to do it last time. You have to go to any components, go to any ball, and now you can specify ball dot y of component. So that's what you need to do, and the component is going to be the parameter ball itself. Are we still doing okay so far with this code? So the parameter ball, B-A-L-L, has no quote-unquote type with it, okay? We don't know what it is. It's just, something. But in order to get to the y coordinates of the ball, we have to say, well, treat parameter ball as if it is a ball sprite, and then give me the y coordinate of that particular ball sprite. Now, if ball itself is not a ball sprite, then we're in trouble, okay? Because if it's just an integer, then it won't actually have a y coordinate. It will give you a runtime error. Okay? When the program runs, it will give you an error. All right. So the next thing we want to do is, well, let's do the easier one first. Distance to west is just the y coordinate, x coordinate of the ball. So we'll just go ahead and duplicate this one, drag it over here, and then change y to x. Okay, that's pretty easy to do. The other two cannot just depend on the coordinate of the ball, because they also have to depend on the width of the canvas. So it will be the width of the canvas minus x for dE. It will be the height of the canvas minus y for ds. So those two are just a little bit more work. We need to do subtraction. So we go to math, and then we take out a subtraction block and say we want to compute the difference between two things. And this is going to be, the first component is going to be the width of the canvas. So once again, we have to go to any components, but this time it's any canvas, and then we try to get the width of the canvas. So right here, just a little more. So we want to extract the width of a component, which is our parameter canvas here. And we want to subtract the x coordinate of the y from the width of the canvas. So I duplicate this block and stash it over here. So that will compute the distance to the east edge. Now we only have the south edge to deal with, which is kind of the same as DE. So we duplicate this block here, and because of the screen size, and where I scroll, it doesn't show the duplicate earlier, but it does now. And then we just have to change the width to the height, and then change x to y, and that should do it. So now we have the 4 local variables initialized: dn, de, ds, and dw. So those are the distances to each of the edges of the canvas from the ball spread. Are we doing okay so far with this code at this point? Still okay? Okay. Now that I have these local variables, the comparisons can be a lot simpler because I can just refer to one of the local variables. The first thing we want to do is to check out, well, let's see whether we have it's closer to the north or closer to the south. I mean, that's one way to do it. So we say less than, okay, and we just need to check. We want to pick out north and south here, so we'll pick out the north, get the value of dn, get the value of ds, and make that comparison. Now, when you do something like this, and you want to remind yourself, oh, but what does it mean if we get to a particular block? What do we do? What do we do to remind ourselves, what does it mean to get to a particular block? What do we do about it? Add a comment. Very good. Okay, so if you think, okay, if I add a comment here, it'll be useful, go ahead. So we just say add comment, and then we click on the question mark, then we can just type away and say, if, okay, we just say closer to north edge than south, than the south edge. And then over here, we can add another comment and basically just say the other one, which is close. Click here first, closer to south edge than north. There we go. So and when you don't need to look at the comment, you can click it again, so it hides the comment. Okay, but it doesn't hurt to insert more comments into your program, because if you don't need it, we can collapse it. But if you do need it, we can just click it, and it shows you what does it mean to be in this block, okay? Which I personally think is helpful. Okay. All right. So now that with this block here, now that we know that we are closer to the north than to the south, what else do we need to do to determine which wall we are actually dealing with? We know the south wall is out of consideration, but we have 3 walls left. Okay, because now it can be the north, can be the east, also be the west. Okay, so 2 branches is not going to cut it. We need, another conditional statement. There are 2 ways to structure this. Okay, and I'm going to show you how to, what 2 ways do we have to structure this. So what I'll do is I'm going to take out only one of these. We'll put in another if then else into here. So now we have 2 more slots, and now we have 3 values. Okay. But this also means, in order to confirm this is, okay, let's say this is the north wall, and I cannot remember the edge to the north wall. So I'm going to look up the documentation again. I drew that picture last time, but I forgot about the edge. So we just have to take a look at this block here. North is 1, 2, 3, 4. Okay, so I got it. So north wall is 1. And we'll just focus on this one here. And then we'll take away this comparison. And the only question now is, how can I confirm that the north wall is in fact, well, the ball is closest to the north, but not the east or the west? How can we confirm that? we cannot use a single comparison. We have to use two comparisons and a logical operator. Okay. So what we do is we go to logic, and then we pick out conjunction. And then we can use comparison. So I'm just going to be a little bit lazy here and just use the comparison for this one, and then the comparison, same thing over here. And then we'll go ahead and change what we're comparing. In order to confirm we are closest to the north wall, we have to say the north wall, the distance to the north edge has to be less than the distance to the east, and also less than the distance to the west. So this is how we can combine two comparisons into one single condition of a conditional statement, and the result of that is, oh, we just confirmed that the north wall is the closest. Is that okay? Is that all right? Okay. All right, so what does it mean if I get here? If I get here, that means the north wall is not the closest one. We also know the south wall is not the closest one. We only got two choices left. We only have the west versus the east. So one single comparison is all that we need to finish the conditional statement. So we'll go ahead. Okay, once again, it's because my screen is too small. So this time I only have to compare the east versus the west. If the east edge is the closest, I think the value is -1, 2, 3. Is it -2, 3? I think it's -3. Because west, no, I take it back. The east wall is 1, 2, 3, and then the other one is -3. There we go. Because the way we draw the directions is 1, 2, 3, 4, -1, -2, -3, -4. So if we confirm that we are closest to the east edge, it should be a 3. If we confirm it's closest to the west edge, it should be a -3. Is that okay so far? How the logic is worked out. Okay. So the else branch here can be pretty much the same structure. So I know that I cannot do it with one single comparison. And so we're going to throw out these things, and we can mimic the structure of the code above here. There are many ways to restructure the code. I'm just going to be replicating what I already have. All right. Oops. Put it here. There we go. But when we get here, we know the south wall is the candidate, not the north. So we just have to change all the distance to the north edge to the distance to the south edge. There you go. And if we can confirm that the distance to the south edge is less than the distance to the east and also less than the distance to the west, then we can just confirm that, oh, okay, it is the south edge. The south edge is a -1, so we duplicate this block, put it here, and specify a -1 to confirm that it is in fact the south edge. Then we duplicate this block, put it here, because if it's not the north edge, it's not the south edge, it has to be between the east and the west, and this block can just work the way it is, because we're just down to the east versus the west. Are we still doing okay so far with this code? Okay, sanity check. There are 4 possible values, okay, because we ignore the corners. So 1, 3, -1, -3 should be possible answers. The question is, do we have all of those as results from the comparisons? Let's double check. Okay. We got 1, -1, 3, -3, 3, -3. So we do have all the potential values. So it passed that particular sanity check. Are there any questions at this point about this code? No questions? Okay. So let's go back to the code to the emulator and see if that part is working. Okay, so I will start the game, and we'll click it, and it's not bouncing. Okay. So it's not quite working yet. So if that is not working, I'm going to take out this block of code and see if the rest of the code is making it stop, which I really doubt. So disable this block, go back to the emulator, start the game again. Oh, it does stop everything. Okay. That's interesting. Well, I think there's another event handler that I might have forgotten. Okay, let me rearrange all the blocks again by category because I want all the event handlers shown first. So we have edge reached, ball when touched. Yeah, I suspect there's one more event handler, but I thought I deleted the whole thing. Okay, let's sort by that's just initialize. That should not matter. It's graying out. Okay, let's see. It has grayed out sort blocks by category, which is what I want. Why is that the case? Okay, let's switch it again. Switch it back. Can I arrange it by category? Nope, it won't let me arrange by category. Well, somehow initialize is called because I think it's because of turning the ball from enabled to false, it stopped. The question is, who is calling initialize game? Okay, that's the right place to do it. I can't see how it is getting disabled. Okay, collect all the blocks. Sort blocks by category. There we go. So we have edge reached, touched, the ball is touched, button one is clicked, clock one timer, and screen one initialize. So nothing here suggests that the ball should stop, but yet it is stopping. Start. And it can bounce just fine, but when I click it, it stopped permanently. And further clicks, it's not active either. So that tells me that it is disabled. So something is calling initialize game to have the ball disabled. But I cannot tell what is doing that. Okay, let's test this. Let's go ahead and change. Let me change the disable part and initialize. Wrong scroll. There we go. So I'm gonna turn this one to true, so the ball will stay enabled all the time, and then we'll see whether the behavior of this program changes. Click, and it does. It keeps bouncing. So it's working the way it's supposed to, but if I So that means someone is calling initialize game when it's not supposed to be called. Is that making any sense? So now we have to find out who can possibly call initialize game. And this is where graphical programming is kind of troublesome, because it's much harder to see, to see the entire program, and I cannot search who is calling initialize game either. So we just have to kind of go through this, really slowly, step by step, starting from this top part of the program. Okay, so this is okay. When button 1 is clicked, we want to call initialize game. So that part is fine, not a problem. This is the definition of initialize game as a procedure, so that's okay, not a problem. And then we scroll over a little bit. Closest wall does not call initialize. Screen 1 initialize would call initialize game, but that's okay because it's supposed to only do it once. And we don't have any other blocks. There are no other blocks in this code. So the question now is, I really don't know why it is initialized again. Very curious. What do you guys think? Okay, first of all, I have an idea of what I should do next. I'll check with you guys and see whether you guys have the same idea or not. What do you think we should do next? We'll just give up and just call it a day. What I'll do is I'm going to package this as an APK, and we'll go ahead and run this program without AI Companion. Okay, because I'm suspecting there's some kind of interference. So that's the first suspicion. So what I'll do is I'm going to build and download the APK file, and then I have to turn off the emulator. Because the code is not making any sense. The behavior of the program doesn't match what the code is specifying, unless I overlook something that's really obvious, which happens sometimes. There we go. We can save the file. And then we reset the connection, which turns off the emulator. Once the emulator is disabled, we have to start it up manually. So we just say, let's see, it's called run emulator. So this time we are running the emulator explicitly, and then we also have to run ADB explicitly too. But that's okay. We'll just give it a moment. Okay, emulator is up. We'll go ahead and run ADB manually. So the first thing I do is I go to the folder where the command is, so I don't have to type long, huge commands. So we go to App Inventor, commands for App Inventor, ADB start server, and then ADB devices, just to make sure the emulator is listed here. Everything is good so far. And then we say ADB install -R so that it will reinstall if it's already here. In my downloads folders, the name is called AUYUNG bounce.apk. It uploads the APK file. It is installed, and it will complain about RM-F, at the end. Okay. And then we switch back to the emulator. We start the app under my name. There we go. Click it. Okay. Now this is still working because I have not put back into the disable code. So we'll go ahead and put the disable code back into it. Go back to the browser. And turn this back into false, and then give us, download another APK file based on the modified code. Switching back to my command line, and this time we have a parentheses 1 because this is the second version, and press the enter key. It will reinstall the application. Even though the file name has parentheses around the 1, the application itself does not. Okay, so it will still be the same application, it's just reinstalling the application. Switch back to the emulator, restart the application, and click start, click it. See, this time it doesn't stop, which is fine. It's not supposed to stop. So something is interfering. So I'm suspecting that the initialized screen is interfering when we run it from AI Companion. That's my suspicion. How do I confirm that suspicion? Take that away from the initialize, right? Okay, let's check that. So now we take this away, we switch back to the other approach. Okay, oh, this is still running, which is good. Okay, so we can now switch back to the browser, and this time we use the emulator from inside App Inventor again. Attack, you got it working already. Why bother to figure out what is causing the problem to begin with? Is there any reason? Should I double check and make sure that okay, this is the problem, even though I know how to get around the problem? Shouldn't I confirm the source of the problem before I confirm and say, okay, this is the right way to get around the problem? Yes. Exactly. Because programming tools are not perfect. They are written by people. All right. So the first thing I'll do is I'm just going to check it out here and see if the problem is persisting. And the problem is not persisting. So this is nuts. Because the problem is not persisting, it's now working just fine. Okay. That's okay. We just continue with the homework then. We'll call that a glitch of App Inventor, okay? All right, so we have to continue the implementation of the program. Initialize HP to 10 and start the game. The ball should start to move, and it should react to touch events. Each time the ball bounces off of an edge or wall, decrease HP by 1, okay? So we need to attach some code to the event handler of reaching an edge. So going back to here, this is a relatively easy thing to do. We just have to find the event handler for reaching an edge, and then we just say, okay, HP has to decrease by 1. So we go to variables, set the global variable HP to the result of a subtraction. The subtraction is going to use HP again as the beginning number, decrease it by 1. Fine, go ahead. And then we use as constant 1 here. There we go. So it will keep subtracting by 1 when it reaches the edges. And you read the homework assignment again. It says right here, if HP gets down to 0, change the background color to red, stop the ball, and announce that the game is over using a notifier. Okay, I didn't say exactly what feature to use with a notifier, so you can use any notifier feature to let people know the game is over. Okay, so where should I attach this code, this logic, to say that if HP gets down to 0, change the background color? I should attach it to the very same place where HP is changed. And where would that be? I just wrote that code. Edge reached, exactly. Right below the code where it checks where it decrements by 1. Okay, so we switch back to the blocks, and this is why I don't like graphical programming, because it's the code is not all over the place. All right, so we need a conditional statement. So we go to control, and then we say if then, and we will say if in math do a comparison, and we'll say if global variable HP is less than or equal to 0, then we'll do the following. Okay, we'll basically stop the game and say, okay, game over, we're done. We have to switch back to the designer, go back to user interface, because I said to use a notifier, so we have to drag and drop a notifier into the components. Go back to blocks. Now we can do something about it. I'm going to move this one out of the way. Okay, so getting back to the homework assignment, it says if it gets down to 0, change the background color to red. Okay, that's the first thing we'll do. And it is the background color of the canvas that we have to change. So we go to canvas, go to set background color, and then we specify the color red, which is right here. Okay, that part is done. And what else do we have to do? We have to stop the ball and announce using a notifier that the game is over. Stopping the ball means we just have to disable the ball. So we have to go to ball 1, go to set enabled, or where is it? Right there. And then we specify false so that we can disable the ball. Okay, go to logic, specify if false, put it here. Okay. If the ball is clicked before a wall, make it bounce back as if it touched the wall, and HP has to increase by 1 in that case. So I haven't done that part yet. But let's check out the program. If it bounces off the wall 10 times, the game should stop. Oh, I forgot one more thing. I forgot to announce using a notifier that the game is over. I forgot about that part. So let's go ahead and fix that first. So over here, I would use the notifier and display a message. And I didn't say exactly how to do it. Show alert is the quickest and dirtiest way to do it. So we'll just go ahead and do it that way. And the exact message is the game is over. I didn't put quotes here, so you can use whatever message you want to use. So I will just go ahead and go to text and specify game over. Like so. Alright, so now I should have almost all the logic in it. Start 1, 2, 3, 4, 5, 6, 7, 8, 9. This should be the last one. It should stop and turn red. There we go. Are we still doing okay so far with this code? So there's only one more thing to do. Okay, I'm not increasing HP by 1 when I click on it before it gets to a wall. That's the only part that I haven't done. So we go back to this code here and rearrange everything because it's difficult to read at this point. And I have to go back to the touch event handler of the ball. And of course, the first thing is to find it first. There we go, it's all the way over here. Re-enable this bounce. So we say re-enable it. And we also have to change XP by 1 or increase it by 1. So we go to variables, we set the global variable HP to the sum of itself and 1. There we go. Alright, let's double check the code and see if it works. So we start the game again and it doesn't want to. Why do you think it's game over all the time? What do you think is happening? I forgot to do one thing. Well, I only initialized HP to 10 at the very beginning, but not at the beginning of each game. So what I need to do is I have to go to the procedure of initializing the game, and let me find where that is. This is the problem of graphical programming, because it's hard to find a particular block. So let's see, can we arrange it by alphabetical order? I thought that's one of the options. Okay. There we go. I have to, when I initialize a game, I also have to change XP to 10. So I go to variables, set XP to 10. There we go. Because we have to restart the counter from 10 when we do this. All right, get back to the code, start again, click, 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 click. All right, so this should give me 4 extra turns. I'm counting, this one is the 4th. 5, 6, 7, 8, 9. If I did not click, it would have stopped here. 10, 11, 12, 13. Should not stop just yet. Okay, maybe I miscounted by 1. Because it bounced off a few times before I clicked it. So that's why. So as far as the game is concerned, I'm done. This is the homework assignment. Okay. Are there any questions about how I did this homework assignment? Yep.
I had a question. What if the coordinates are a tie? If x and y equals 20, so then it's not less than the other.
Should have used this one, but in the code it would have a preference. Because if the less than is false, it will go for the other one.
Okay.
So that means if you want to check for the -4, 2, the 4, and the -2, then you basically check whether they are the same or not. So you have more stuff to do in that case. Is that okay?
I think it is.
Okay. Any other questions about this program? No questions? The one more thing I can do, but it's not part of the homework assignment, is when we start the game, I can randomize the location of the ball. Okay, that makes it a little bit more interesting. So to do that, we can go to Initialize Game, and every time we call Initialize Game, it will also change the position of the ball, kind of to use a random number for that. So to do that, we just have to go to ball 1 and go to set the X and set Y, and we just go ahead and specify a random number for both the X and the Y. So we duplicate this also, and we just randomize this. So we go to math, we go to random number, okay, pick a random integer from within a range. So we duplicate this block here, and I cannot use 100. That's not a good number to use, because I should use the width and the height of the canvas. So we go back to canvas, and then we pick out the width for one of these for the X coordinate, and then for the Y coordinate we have to pick out the height. So we just duplicate this block and change the width to height. There we go. So this time, every time I start the game, it will reposition the ball kind of randomly, and it won't start in an edge. There you go. And I start again, it will start from a random location, just like that. If I click it, it should bounce, 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 and bounce. There we go. Any questions? What do I need to do to also make use of the corners? Remember what I said? I'll get the 4 edges first, and then I will try to accommodate the other ones. So what do we do? How do I confirm that it should be a -4? I will check for the corners first, okay? Because the corners are more restrictive, so that's what I should check first. Okay? So how do I confirm it should be a -4? Okay, so let's go back to the code here, and we'll expand the code. And in fact, we'll go to the procedure that we just wrote over here. And this time, I'm gonna chuck all of this code into the trash can and start from scratch. Okay. All right. We go to control. Same old, right? We just say if then else, but it has to give me a value back. Okay. There we go. And what I'll do is I'm just saying, okay, I just want to confirm that we should use -4. So now the question is, what condition do I use to confirm that this is the northwest corner? What should I do? It's not going to be a very simple expression. It's going to be a little bit long and tedious. But how should I confirm that? Okay, what makes a corner a corner? Equal distance between, in this case, equal distance, the distance to the north and the distance to the west should be the same. Okay, let's check that first. So we try to make those components step by step. So we go to math and then we say, okay, this time we are in fact checking for equality. But it's going to be inside some kind of conjunction. So I already know this is going to be a conjunction with an and. So we put this one here as the first component. So the first thing we want to do is to say the distance to the north and the distance to the west has to be the same. That's the first criteria to choose to use the value of -4. Is that okay? And then the second criteria, and also the third one, is it has to be closest to these two edges and to all the other edges. So we can confirm that using 2 additional comparisons. Okay. And there's nothing that says you cannot use a and inside an and. Okay? That's nested construct. In programming, you will see a lot of times this is permissible. In fact, it is the only way to get something done, is to put a block inside another block. Okay. So in this case, now we have 2 additional comparisons that we can do. So we'll go, I'm just too lazy to drag and drop all the comparison blocks, so I'm just going to drag and just copy this one a few times. Okay. Now that we have confirmed, because by the time I get here, I have already confirmed that the distance to the north and the distance to the west are exactly the same. So whichever one I use for this further comparison, it doesn't really matter. Okay, I just need to confirm that they are both less than the distance to the west, not west, east, and also the distance is also less than the distance to the south. Then I'm good. Are we doing okay so far with this kind of long-ish conditional statement? Or long condition. First part confirms that the distance to the north and the distance to the west are exactly the same. Second condition, the distance to the north is less than the distance to the east. Third condition, the distance to the north is less than the distance to the south. That's all I need. So that's all I need to confirm that this is a -4, the corner. Okay, so if that is done with a -4, let's see what we can do with a -2. And lazy as I am, this is what I'm going to do. But this time I have to tweak it a little bit, because the 2 edges or the distance to the edges where they must be the same is no longer the distance to the north. This time it is distance to the south versus distance to the west. They must be the same. And the value that we have to specify is a -2 in this case. But we still have to confirm that these 2 distances are shorter than all the other distances, but we just have to change dn to ds, dn to ds, ds to dn, and we're done. Is that okay so far? Okay. How do we confirm this should be a 4? We duplicate this block here, stash it over here. So the value this time we're going after is 4. But in order to use 4 as an edge code, we have to be at equal distance to the east and to the south. Okay, that's the first criteria. So now we say, the distance to the south and the distance to the east must be the same. And then the distance to the south, pick one, okay, it doesn't matter which one we pick because they are the same, has to be less than the distance to the west and also less than the distance to north. Okay, so that part is already done, so we're good. 4 is already confirmed, and then the only one left is 2. So we duplicate this block again, put it here, and say that the distance to the east and the distance to the north must be the same, and then pick one of those and just say that the distance to the north is less than the distance to the west, and the distance to the north is less than the distance to the south. And this is how we confirm that the value 2 should be used. So we handle all the corners like this. But using this kind of code, I can also confirm the individual edges. I can now specify 1, 3, negative 1, and negative 3, pretty much the same way. Okay, let's see how we can do that. So I'm going to finish up this entire code by this kind of structure. I duplicate this one more time, and this time I want to confirm a 1, which is the north edge. So that means the distance to the north edge has to be less than the distance to all of the other edges, right? So we just say, hey, the distance to the north has to be less than the distance to the east, and the distance to the north has to be less than the distance to the west, and the distance to the north has to be less than the distance to the south. Okay, we got it. Are we still doing okay so far? Now, I can tell you right now the code does have a flaw. Okay, that's really hard to spot. Okay, but I'll finish this first, and then I'll ask you guys, hey, of all of these things, there are certain things, or at least one case that is not caught by any one of these conditions. I'll talk about it later. Okay, so just keep in mind this logic has a little flaw that will not show up most of the time, but when it does show up, it's nasty. Okay, so wrong thing to duplicate. Duplicate the entire conditional statement. Stash it here. This time we'll deal with 3, which is the east wall or the east edge. So we just have to confirm that the distance to the east is less than the distance to everything else. Okay, distance to the north, distance to the west, and distance to the south. Duplicate the block, put it here, and this time we'll deal with the south, which is a -1 here. So the distance to the south has to be less than the distance to everything else. Okay. And I'll do one thing that doesn't seem to be necessary, but I'm going to do it this way. So we'll duplicate this block, put it here, because ideally speaking, by this time I should know this should be a -3, because it's not any one of the other 7 edges, so it has to be whatever is remaining, which is a -3. But I'm going to put in here just to say, hey, this seems to be a duplicate, and it should not be necessary, but because of a flaw, something is going to happen. Okay, so now we have distance to the west being less than everything else. So distance to the west is less than distance to the north, distance to the west is less than distance to the east, and distance to the west is less than distance to, oh, forgot. Was it south or, okay, yeah, south. There we go. All right. And the value should be a -3 in this case. All right. So now the question is, what about this little slot here? Will we ever get here? Can we possibly get there? That's the question. What do you think?
You get center.
Exactly. If it is equal distance to all 4 edges, then the less thans won't work. And you just have to fail one of the less than because they're all conjunctions. So if it fails one of the less than, the entire conjunction is false. That is the flaw of this program. That's why it doesn't work. when you are right at the center of the entire thing. How do we fix it? Instead of all the less thans, we can specify less than or equal to. That's one way to fix it. Is that okay? So you just have to go back and change all the less than to less than or equal to. And that's about it. But this is one of the flaws that is really hard to catch, because the chances of you clicking on the ball when it's right at the center of the entire canvas is very, very slim. And if it does happen and your ball doesn't bounce, or doesn't bounce the way it's supposed to, you would miss it. Okay? You can quickly discount and go like, oh, maybe it's just a glitch, and not register and say, oh, maybe the logic of the code has a problem. Is that okay? So I'm going to fix up this entire program, put it onto Moodle so that you guys can download it, and if you want to analyze the code, be my guest, okay? And in fact, I want you guys to download it and document it. Just put in your own comments, okay, to explain to yourself, what the program is doing, what the procedure is, and so on and so forth. And you can kind of tell that this is really, really tedious, because I have to change all of these blocks here. Okay, so I think that should be it. And I'm going to export selected project to my computer, and then we can upload it back onto Moodle. Back here, so back to Moodle. I am going to update the project and include the solution. So this way you guys have the solution that we just worked on today. Go. Okay, so do you guys want to talk about your experience with working on this homework assignment? Was it easy, hard, just kind of tedious, or?
It was hard.
It was hard?
Yes.
Which part was hard?
Maybe the last one, that we did comparison.
All the comparisons, the logic, to figure out which ball is closest to the ball. Okay,
Yeah.
all right. Any other opinions? I mean, anything? No? So you find the logic to find the closest ball to be, well, it is tedious for sure.
Yeah.
Okay, it is tedious for sure. But there are different ways to do it. You can structure it differently. Like the first time I did it, I used a structure, nested conditional statements to do it. And the second time I do it, I use conjunction. So you can use one or the other, or both. Okay, sometimes. Anything else? I mean, and do you guys want to tell me, how it went when you wrote this code? No. How long did you spend on it? If you don't mind me asking.
It's been like 3-4 hours.
3 or 4 hours. Okay. But what do you think is the outcome of these 3 or 4 hours? Do you think you are more familiar with App Inventor, what you can do in App Inventor?
Yeah.
Okay, well, so it's not time wasted. Okay, 3 or 4 hours is not too bad. Okay. Anyone else? Does anyone spend more or less time? No. What was the main challenge? That? But did you guys think about, okay, so when you think about how to code something, the first thing you might want to do is to figure out, how do I do it? Okay? So you give yourself a scenario, okay? This is where the ball is, okay? And this is the size of the canvas. How do I know, how do I figure out which edge is closest to the ball? Okay, but don't rely on visual stuff, because we are very visual beings. So we can visually say, oh, the ball is closer to the north. Okay, so work on the numbers. How do you know that it is the north edge? That is what you need to do to say, okay, if I know how I do it systematically, then I go find the necessary blocks in App Inventor to duplicate the logic that I use in my mind. Okay, so the first thing you have to do is to figure out how you can do it in a systematic way. Don't even think about the blocks. Don't even think about App Inventor. Just say, okay, but how do I do it? Just using the numbers, how do I figure out which edge is the closest? Is that helpful or not?
Yeah, but I think the hardest part was trying to activate the tree to basically figure out, okay, so maybe once you're testing this is done, then you go through and test this. Yeah.
What you've done, once you check already, which is something.
Yeah.
Right, and that's why the way I did it here is kind of easy in a way, even though it looks really messy, because each condition is self-contained completely. It's like, if this whole thing is true, I know it has to be this corner. It cannot be anything else. Well, what if it's not? Well, then it's one of the other 7, right? So that's why this approach has that kind of uniqueness of each condition qualifies one particular edge completely. It's like it doesn't depend on anything else. If that condition is true, I know for sure this wall or this edge is the closest. So that's one advantage of this approach, as opposed to a structure of these conditional statements. Then you have to track, okay, how did I get here? True, false, and then true again, or what, right? But eventually it boils down to something like this. And this is problem solving, if you have not taken, or if you're taking cisp300 in the same semester, that's what you'll be learning in cisp300, is how to solve problems by casting the solution of a problem in a programming construct. App Inventor is just one additional way to express the solution. Instead of writing out your program in C, C++, or Java, or Visual Basic, now we're dealing with blocks. But it doesn't really add anything, it doesn't remove anything compared to other programming languages. Okay. Any other comments, feedback?
Just difficult to figure out which block we should use.
Because you have to kind of make a mental catalog of all the blocks available.
Otherwise, visually it's understandable.
Yeah.
What we should do, but which block we should use, which
Yeah,
one is
well,
better on the
yeah.
right one.
But now you're much more familiar with the
Yeah.
blocks than you were before. And that's part of the purpose of the homework assignment. Because if I told you guys and said you have to study all the available blocks and figure out what each one does, nobody's going to do it.
Yeah.
If I give you a homework assignment, then you would go explore and go like, okay, which block should I use? Let's check out this one, let's check out that one, and so on. So that's partially what I actually want you guys to do, is to explore a little bit, and go like, maybe this block will do it, maybe not. But that's actually studying. You're exploring the tool and what kind of feature is available to solve the problem. Okay. Any other comments, feedback? There's no homework assigned today, so you guys are off the hook for 2 days. No, this is Wednesday already. So
Monday.
Monday. Until next Monday.
Yeah.
Well, I might send an email to you guys if I have a new homework assignment. Okay, because I want to get you guys ready for the midterm. I don't want you guys to go into the midterm not knowing what you'll be doing. Okay, I can tell you already the midterm is going to be a practical midterm, which means I will ask you to code in the midterm. So you guys will be in the lab. Okay, we'll use one of the either lecture or lab session. You guys, I'll give you a problem to solve. I'll describe. It's kind of like a mini homework assignment. Okay, I'll describe what the program is supposed to do, and then you guys can work on it. Okay. So knowing what blocks are available is going to be helpful, and I will try my best. Okay, I try to promise you, but I don't want to break my promises. But I will try my best to make sure the solution of whatever you need to do in the midterm will only involve blocks that we have talked about up to this point. Okay? So that might be helpful. Which also means you might want to download the solutions to all the other homework assignments and just check out everything. Go like, okay, do I understand this? Do I understand this? Do I understand this? If you don't, it's okay. Bring your questions to the class or just ask me by email, by messaging, and stuff like that. Okay, but you do have to go over all of those things just to make sure that you are okay with all the concepts. Yes?
Will you put this lecture on YouTube?
Let's see, what time is it? It's 25. I do have a meeting to go to. I can probably do it during the meeting. The meeting is in 128, where there are computers, in front of everybody. So while I'm in the meeting, I can probably upload the notes for today. Nobody will know. Okay, so the cisp300 is not canceled. Okay, so I will be in 129 just in time for cisp300. In fact, I'll be right next door for the meeting, so I just have to walk over to 129. Okay. All right, so I'll see you guys on Monday. Have a nice weekend. The weather is really nice. You should go outside and do stuff. As should I. Yep. No, I forgot about it.